Hello all, welcome to Tech Vistas. In this video, we will talk about homomorphic encryption. In typical encryption schemes, whenever any sensitive data or information, we need to send it to some receiving server from any server. So what we do, we first encrypt that data or information using some encryption keys. Then we transmit that data, and after the receiving server or user gets that data, it cannot basically understand what is the meaning, what is there in that data, right? Because it is encrypted. So that server will first decrypt that data, then it can process it, right? But what happens in that case when the receiving server get hacked? So even after we did so much effort like encryption, decryption, but after decryption at the receiving server end, the system got hacked and data is leaked. So let us understand the various typical encryption schemes or use cases where how it is used in real world now, and what is the solution we have that even if data is hacked at the receiver end, we will be safe. So first example is basically a hospital, like which normally have the information of patients, their diagnosis reports they have, which is quite sensitive data, right? So when they send this information to any third-party analytics server, suppose for some analysis or some diagnosis reporting, so how they can basically secure it? So the typical way is to encrypt that data using some encryption keys, then send it back to the third-party analytics server. Now, third-party server will basically decrypt that data, and it will process it, whatever is required from the business point of view. But the same risk also here, right? Suppose third-party analytics server get hacked. After decrypting that data is all at risk, right? When if it was encrypted in from the hospital server, it was also encrypted in transit in on the wire. But when it reached to the third-party analytics server, because they decrypted it, so now they are processing it, and in meantime, it get hacked or somebody it found it. So it's not good, right? From the because sensitive information is leaked. So also like second example, we'll take about any financial institution or like cloud user, right? Suppose company want to use some cloud infrastructure like the public cloud like AWS or Azure, and they want to do some processing, or they want to basically use the computational power from the cloud servers, right? So what they will do, they will again do the same thing. They will have some file, right? They will encrypt it with some encryption keys and send to the public cloud. Now at the public cloud, and that can be stored as encrypted, but it won't be much helpful, because until unless you decrypt it, you cannot you basically process it. So we have to decrypt that data and then process it. But same risk also is, suppose the public cloud gets hacked or somebody intentionally breaks into the cloud servers, then the data is at risk. These are the typical scenarios where we are doing everything to get our data. We are encrypting it. We while sending data, it is encrypted. But during processing time, it is not encrypted because it's not possible to process the data in the encrypted form. So the solution we need, right, for that. So how can we process that data without decrypting it? The solution is basically the homomorphic encryption. So in this scheme, there is no need to decrypt the data for processing it, because in the homomorphic encryption, we can process the data without decrypting it. So that is the main feature of this encryption scheme. So even if we can uh, do the complex mathematical operations also on that data without decrypting it. So the main difference between the homomorphic encryption scheme and the other typical encryption scheme is that in the typical encryption scheme, we must decrypt the data before we can process it. But in this encryption scheme, we are able to process data without decrypting it. Let's understand this better using a diagram. So here you can see we have an end user that have some sensitive data in plain text. Before sending this data to the cloud server, it is going to encrypt it using the homomorphic encryption scheme. So when this data is sent and stored into the cloud server in the encrypted form, that cloud server cannot read it, right? Because it is encrypted. Even it wants to do some processing or like perform functions or some batch jobs on their data. It can do because it is this encryption scheme is such that we are able to perform business functions or analytics on the encrypted data itself. We don't need to decrypt it. And now after we get results that can be decrypted by the end user itself. So in the whole process, data can be leaked because it is already encrypted at the user's end, and whenever we are sending it, either in transit or at rest, it is always encrypted. So there is no chance of leaking the data or hacking by somebody. Even if somebody hacks into that data or their server, they cannot make sense about that because it is already encrypted. So, so let's understand how the homomorphic encryption scheme works. So, this is very complex mathematical process, but to understand this, I have taken a simple example of like two numbers addition. So, suppose a user want to do the addition of two numbers, and they get some output right as a plain text form. Now, this mathematical operation or data, they want to send it to some cloud server or third-party server for some processing. So if they send this whole data in a plain text form, then they'll be able to see, okay, this is the numbers or whatever data we are sending it. Then what user will do, they will use the homomorphic encryption scheme, and they will change the data in such a way the relationship between the data is not changed. So even if data is not same, but relationship among those that inputs are always same, and whenever they decrypt it after the processing, they get the data back, right? So this is, I mean, it is not that simple, but I just gave the example to understand it. Like basically, the main idea here is whenever we we want to process any data which is encrypted in homomorphic encryption scheme, the relationship is maintained between after the encryption also. So whatever data is there before the encryption and after the encryption, they are not same, but they will have a relationship maintained so that whenever any third party analytics server or some processing is happening on their data makes sense because that is still in the form of read. I mean that can be readable as well, right? So let us see the various types of the homomorphic encryption scheme. So first is the partially homomorphic encryption scheme, like the PHE. So in this, we can perform only one kind of mathematical operation, like only addition or only multiplication. But number of times we can perform it is infinite. So either we can perform the addition infinite times, or we can perform the multiplication infinite time. So basically, there are some mathematical models by which we can achieve it. Second is the somewhat homomorphic encryption scheme, the SHE. It allows both addition and multiplication, but limited number of times, right? And the third one is the fully homomorphic encryption scheme. It allows both addition and multiplication in this scheme, and it can be done infinite time. So these are the various encryption schemes. Basically, these are like some mathematical models that can be used to basically perform this homomorphic encryption. So, to conclude that the homomorphic encryption is very good, that in the sense that the data is always encrypted like from origin to the destination, and even the processing can happen without decrypting it. But the commercialization of this scheme has not been done at large scale because the performance is very poor and there's high cost because the computations are very complex, and that's why it needs a lot of computational power to perform this kind of encryption on the data. We have like some open source implementations like Seal from Microsoft and HE Live by IBM, which support the FHE, like the uh, uh, fully homographic encryption schemes. But these are not widely adopted by the commercial users. But yes, the work is going on, and if this scheme or this encryption scheme is commercially adopted, then it will make our data more secure, and we hope for that happening very soon in near future. So that's it. Thank you for watching this video. Hope it added some value to your knowledge, Kitty. See you next time. Please leave comments or questions. I would try to address them. And please subscribe. Thanks again.